Okay, we have our hand created, but if we press play, nothing happens. We want our hand to be able to rotate. So how do we do that? Well, we're going to do that with a script. And remember before, we want it on the second hand holder. So I'm going to press add component. If I add component, I can actually add a whole bunch of different things. Right down at the bottom, it's new script. I'm going to call it hand rotator. I like to use nouns here, and I'll explain why in a bit. I'm going to create and add. You can see it's been created here. It also appears in our assets folder. I'm going to double click on that, and it's going to open up Visual Studio for me because I have downloaded Visual Studio. If you haven't, hopefully I'll be able to copy and paste this code onto the bottom of my blog post, and you can copy and paste it. Or you can download Visual Studio yourself, which is really nice. It has a whole bunch of keywords and whatnot. It'll highlight the keywords, so it'll be different than what we're looking at. For instance, void and start are both keywords. Float, time skip. Time skip. If I wanted to, float is a keyword. Time skip is just a variable name, so it's not going to be highlighted at all, but you'll notice these are blue. These are sort of light gray. On my other computer, they appear green because they're very important keywords. We don't need this at all. What we do need is a rotation speed, because we want to say how fast is our hand going, and we're going to start that with the keyword in these square brackets, serialize field. Float rotation speed. Now, what does serialize field mean? It's sort of an access modifier. Remember in Java we had public and private. So public meant basically any class could come along and change it, and private meant only this class could come along and change it. Serialize field is sort of halfway in between. So I'm going to save this, just Control S. So serialized field means it's private to other classes. And what that means is that classes can't change this without getters and setters, and we're not going to use those. So no other class can come along and change this. What happens is if I highlight my second hand holder, I can see this thing right here. So I can change it to 5 if I wanted to. So it means, serialized field means that I can change this in the inspector, but I can't have other classes change it, which is very useful. If you have programmers and you have game designers and they are separate people, game designers might not know which variables to change. So by having them available in the inspector, you can change them without having to go into the IDE, in this case Visual Studio, and change them there. I'm just going to give it a default value of 1. But what happens is that this, if I put a value in here, it overrides anything I put in here. So a couple other things. We have start and update. Start is called when the object is created. There's actually 3 different methods that get called. There's awake, start, and enable, in that order. So they get called only once. Update gets called every frame. And by frame, it's every time anything needs to be rendered. So basically what happens is Unity will do a whole bunch of calculations, and then it will render everything in the scene. And then it will do a whole bunch of calculations and render everything in the scene. And it just does that over and over and over again on update. So what we're going to do now is say Well, let's get the game object first. Game object. So this references the game object that this script is attached to. Well, let's take a look at everything available. You can get any component that's attached to that game object as well. You can get its name. You can set it active, which means basically turning it off and turning it on again. And then a whole bunch of other things as well. What we want is the transform. So all we're doing is getting the rotation. Actually, we're setting the rotation. So position, parent, local position. Let's get rotation. We could get what the rotation is right now, but there is actually a very special method called rotate that we're going to use. And this is just rotates it around something. Generally an axis, a vector 3. So if you remember back to high school, a vector is not just a scalar number, it is both a scalar number and a direction. So a vector 3 has 3 numbers instead of just 2. And those numbers are usually the x-coordinate, the y-coordinate, and the z-coordinate. So we are just using the y-coordinate. So new vector 3, let's go 0, 1, 0. Actually, not just 1, we are going to do rotation speed, because we want it to rotate around the y-axis by the rotation speed that we set up here. So let's save this. Go back to Unity, press play, and see what happens. Wow! Well, it's moving. It's going pretty fast. It's booking it. And if you pay attention, it can get a little uneven. And that's because this is happening every frame. But our frame rate is not consistent. In fact, if we wanted to, we could turn on stats and we can actually look at what our frame rate is. So, what is our frame rate? All the way from 160 to 240, I thought. So if we're calling the same method every frame, it's gonna vary a lot. Luckily, there's a couple things we can do. There's more than just this update method. We could go void fixed update. Fixed update means this happens not just every frame, every set amount of time, and usually it's every 20 milliseconds, but we can change that if you want. But the easiest method I found is something called time.delta time. I love time.delta time. Basically, what it means is how much time has elapsed since the last frame. Since you last did any calculations, how long has it been? So if we save this, go back to here, this gets a lot slower because with 200 frames per second, the time since the last frame is going to be about 5 milliseconds. So it's being multiplied by 0.005, which means this gets a lot slower. But it also gets smoothed out, since any fluctuations in frame rate don't matter at all. Maybe we should speed this up. Should we put 60? Let's see what 60 does. Oh, now it's booking it. It's taking maybe 4 or 5 seconds to get around there. Do 10? Does 10 work? If we wanted to, we could probably time it and get an exact number. But it's not particularly needed. One thing I do notice, though, is that we should probably save our progress. So let's go File, Save. And it's just going to save this in Scenes as our sample scene. If you don't want to overwrite sample scene, even though that's what it automatically starts up as, you can save it as something else by simply doing save as clock scene if you wanted. Anyway, we have our second hand holder, and it's rotating nicely. What we really want is probably a minute hand and an hour hand.